Hello friends, welcome to engineering tutorial. So we will from the next series of videos we'll be discussing some numerical problems, some questions on the topics which we have covered previously in thermodynamics, which is heat and temperature. Okay, so we have covered all the theoretical concepts, all the important mathematical derivations, formulas, everything. So first you watch all those videos and then come to these series of videos which are the numerical problems on those topics. So the first series of videos on this, it will be on temperature measurement and temperature scales. So different scales which we have discussed and related to that. So the first question, which is a very short and very basic one, it is given that if the temperature of a room is 20 degrees Celsius, then what is its temperature in degree Fahrenheit? So here we'll be using the basic formula, okay, of temperature conversion. If you remember, suppose we are trying to convert temperature from, let's say, a scale 1 to a temperature in scale 2. So here first we take the temperature reading in scale 1 minus the lower fixed point of scale 1 by the upper fixed point of scale 1 minus the lower fixed point of scale 1. This is scale 1. That is equal to the temperature reading in scale 2, the equivalent of temperature reading of scale 1. Okay, so these are the interconversion formula, minus the lower fixed point of scale 2 by upper fixed point of scale 2 minus lower fixed point of scale 2. So here this is in degree Celsius, this is in degree Fahrenheit. Okay, this is in degree Fahrenheit. So here this reading in degrees Celsius, it's the same as this reading in degree Fahrenheit. All we have to do is substitute the values. So here this TS1, it is given 20 degrees Celsius. The lower fixed point, which is the ice point in degrees Celsius, the melting point of ice, that is 0 degrees Celsius. The upper fixed point, the steam point, the boiling point of water, 100 degrees Celsius. And this again the lower fixed point, that is 0 degree Celsius. For Fahrenheit, we have to find this equivalent. This is question mark. The lower fixed point, which is the equivalent of ice point in degree Fahrenheit, that is 32 degree Fahrenheit, and this upper fixed point, that is 212 degree Fahrenheit, which is the boiling point or steam point, and this is again lower fixed point, that is 32 degree Fahrenheit. So here when we make these substitutions, we arrive at this. So we have 20 minus 0 by 100 minus 0 is equal to this in Fahrenheit, which will keep it as TS2, or TF, you can also substitute that, but here we'll take it TS2, minus 32 by 212 minus 32. That implies 20 by 100 is equal to TS2 minus 32 by 212 minus 32, that is equal to 180. That implies, I am taking it here, okay, that implies here 1 by 5, that implies 1 by 5 into 180 is equal to TS2 minus 32. Okay, that implies TS2 is equal to 180 by 5 plus 32. Okay, so 180 by 5, that is equal to 36, and again 36 plus 32, that is equal to 68. So this temperature, which is in degree Fahrenheit, so here that is equal to TS2, which is temperatures in degree Fahrenheit, that is equal to 68 degree Fahrenheit. This. So here the important thing is to remember this formula. Okay, this formula, which is very important. Okay, so this is the first question. So here is another question on temperature scale and temperature measurement related to heat and temperature. So it is given that a faulty thermometer has its fixed points marked at 5 degree and 95 degree. Okay, so here the exact scale that is not given, it's just given that 5 degree and 95 degree, they are the fixed points. Then it is asked, what is the correct temperature in degrees Celsius if the reading on the faulty thermometer, that is 59 degrees Celsius. So when you come across these kind of faulty thermometer related questions, here also you will have to use the same interconversion formula that you use to convert temperature in one scale to another scale, like we discussed previously in the previous question. So here what you have to do, first on one side you write the faulty scale, okay, and on other side the scale in which the reading is given. Okay, so here it is not actually degrees Celsius, it is just 59 degree, no degrees Celsius. Okay, because it's not mentioned which degree. Okay, it's just 59 degree. By mistake I've written. Okay, the reading on the faulty thermometer is just 59 degree. So here we have Celsius scale. So the conversion formula is temperature in one scale. Let's say we denote the temperature on the Celsius scale as T subscript C, minus the lower fixed point, which is the ice point or melting point of ice in Celsius scale, that is equal to 0 degree Celsius, by the upper fixed point. The upper fixed point temperature in Celsius scale is the boiling point or steam point, it is 100 degree Celsius, minus again the lower fixed point, that is equal to 0 degree Celsius. That is equal to now the faulty scale. For the faulty scale, the reading this on the faulty scale, or the wrong scale we'll call it, because it can confuse us with Fahrenheit if we write subscript F. So the wrong scale, the reading on the wrong scale which is given, that is equal to 59 degree. So wrong scale reading minus its lower fixed point, even if it's wrong, but we have to take it. What is the wrong lower fixed point? So the wrong lower fixed point is 5 degree. So here we'll put 5 degree. Okay, then the upper fixed point, is here 95 degree. So here again we'll put it 95 degree, the upper fixed point, and again the lower fixed point, which is 5 degree. So this much is equal to this. This is the conversion equation. Like we do in any other scale, we convert it to the second scale, we'll do it in the same way. So for the faulty scale, we'll take the wrong reading minus the wrong lower fixed point then the wrong upper fixed point minus the wrong lower fixed point. Even if it's wrong, even if it's faulty, we have to take it, because we want to calculate the equivalent right temperature of this wrong reading. Okay, whatever this wrong reading is, okay, we want to find the correct equivalent temperature in a particular scale. That's why this conversion equation is very important. Okay, so now if we try to solve it, then it is equal to 59 minus 5, that is 54, 95 minus 5, that is equal to 90, that is equal to Tc minus 0, simply Tc, by 100 minus 0, that is equal to 100. That implies temperature in Celsius is equal to 54 by 90 into 100. So 0, 0 gets cancelled, 954, that is equal to 6, equal to 60 degrees Celsius. So the correct reading, that is equal to 60 degree Celsius. It is the correct temperature reading. Okay, so this is another very good question related to faulty thermometer, where we have to convert the wrong readings into the right one. Okay, so this is the second.